So we've all taken our driver's ed exam where they ask you the question, at what speed does hydroplaning occur? And if you pass the exam, you would know that the lowest speed that hydroplaning can occur is 35 miles per hour. But exactly how does hydroplaning occur? This phenomena happens when water enters the grooves of the tire as it's going across a wet surface, and it creates a hydrodynamic pressure between the water and the wheel. And as the tire speeds up, this hydrodynamic pressure gets greater and greater, creating a lift force upon the tire. And with this lift force, it eventually gets to a point to where the tire is basically riding on top of the water rather than the ground, eliminating all the traction between it to where the driver can lose control.
Right.
Okay, so for the math part, this phenomenon is based out of the Bernoulli's equation. And for our case, we're only going to emphasize the hydrodynamic pressure of it. So you take this as one variable, P, which is going to be used for calculating the drag force later on. But essentially what it says is that if the fluid is flowing faster, you're going to need less tire speed for it to hydroplane, which then takes into where it comes into the formula that we used to model our system was in MATLAB, which says that the sum of the drag forces equal to the friction force, and these drag forces account for air and the tire rolling plus the water. We're only, for the sake of this course, we're only looking into the drag of the water, and the others are a formula that we found on an experimental paper. So what it says is that the drag due to water is 4 times the hydrodynamic pressure times the area of the water, and that goes into saying that it equals the sum of those drag forces equal to the friction force, which then can be rearranged into getting a velocity equation for your tire in order for it to hydroplane. Which again, we used a MATLAB calculation to get an approximate speed for the tire.
Right, and this is our experiment. It's a wheel on a track running up and down an inclined plane. It should be able to go all the way up, but as we drop water into it, it should hydroplane and stop in place. It's super grippy, so don't fully slide down, but it should stop in place. Let's see how it goes. Just so I have 2 takes of it. And pinch it.
Well, I think